Good morning, everyone. My name is Jorge Pacheco, and I'm from Federal Institute of Bahia, Brazil. I go to present the research named as Web of Things Data Visualization from Device to Web via Phone and Cloud Computing. We're so sorry for not being present at the conference. So, in that presentation, I'll talking about the research context, next about our proposal, the prototype, the evaluation performed, and finalizing with future works. We use in our research IoT, data visualization, and fog computing. The Internet of Things is an emerging paradigm for connect physical objects to the Internet, providing them with the ability to communicate with others. This device produces and transmits large amounts of data over the Internet. This context represents an opportunity to develop approaches that enable effective data storage and processing, as well as data visualization, whose interpretation should be clear, efficient, and easy. This represents a real challenge in data visualization. This way, fog computing is present as an alternative to some of those challenges, because of offer computing, storage, and communication services near to IoT devices. Such features is essential in IoT and WOT application, as they require support for mobility and geo-distribution, in addition to knowledge of location low latency. We propose to create a model to WOT data visualization in a fog compute perspective, more specifically in a fog of things perspective. Fog of Things is a new way for design and implementation of fog compute platforms for the Internet of Things. Like in fog computing, part of data processing capacity and service delivery operations are performed locally in small servers, and data processing that demands for heavy computational resource can occur in the cloud. We aim to define a model for data visualization that organizes the presentation at different levels of abstractions. A platform based on Fog of Things must contain some components like FOH devices, FOH gateways, FOH servers, and applications. In this figure, we observe the FOH devices at level A, which monitor the active environment. The processing and storage capabilities are usually constrained, so it's necessary that the device sends data to a Fog of Things gateway at level B. In this case, data is processed and stored for a short time, since the capabilities of storage and process of gateways are limited. The data is only temporarily available before being sent to a FOH service at level C. At this point, it is possible to realize some treatment like filtering or aggregation in order to reduce the data volume. In servers, it is possible to process and store a large amount of data. Like in gateway, we could transform data before sent to cloud. In the cloud, data becomes available for a long time in large volume. At this level, the heaviest task of process is performed. Thus, at each level, the data has different aspects. The data that goes from low to high level becomes older and its volume becomes small in comparison to the former volume. Therefore, the visualization for such data needs to be adapted to every situation. Our approach intends to provide multiple forms of visualization over the same dataset, since each generation in devices until storage in the cloud, passing through gateway and servers. As proof of the concept, we developed the WOT visualization prototype. Here we have our architecture scheme. We use a REST API as a common interface between visualization applications and data source. In this way, communication occurs in a similar manner regardless of implementations and technologies used. Actually, Our prototype implements the data access object for a triple store. Here we have the prototype homepage. Use HTML, CSS, and JavaScript language, and some frameworks like Bootstrap, jQuery, and Google Maps API. We plot sensors as markers on the map using their coordinates. On the left side, we have a menu where it's possible to add new triple stores endpoints with sensors data. Sensors are clustered by kind, and with a checkbox, we can plot or not a specific cluster. On the right side, you have a map where sensors are plotted, and we can observe specific information about sensors or clusters from a mouse click. When users click on any sensor or any cluster, a new window appears containing the most recent sensor measure and a graph with historical data. For example, here we have information about clusters with humidity, dew point, and temperature sensors. In this case, data was present as an average. By clicking over the sensor name, historical data are present in the graph. Finally, we performed a usability evaluation of the WOT visualization prototype. We used the user questionnaire developed by Lounge. This technique suggests that users evaluate the products using 4 dimensions: usefulness, ease of use, ease of learning, and satisfaction. We created an HTML evaluation form and made it available on the web. In addition, we provide the prototype online for users' evaluation, and each question was rated using 7-point Likert rating scale, ranging from totally disagree to totally agree, where rates between 5 and 7 we consider as good acceptance, rates between 1 and 3 we consider as rejection, and rates of 4 we consider as neutral. Finally, we had 8 answers made by masters and PhD students in different areas of computer science not related to data visualization. As a result, we obtained 77 reported good acceptance, while 3 reported rejection for usefulness. 69 reported good acceptance, and 11 reported rejection for ease of use. 91 reported good acceptance for ease of learning, and 77 reported good acceptance, while 11 reported rejection for satisfaction. These results represent a good acceptance of your prototype, but this is a work in progress, and it's necessary to attack some relevant points. Thus, as a future works, we need to develop different data visualization techniques, as well as methods for mining. Today we implement only simple techniques, allow the use of different ontologies in the endpoints. Nowadays, only the first ontology is used. Complement the implementation of the REST API by adding access to other levels on the Fog of Things architecture, and perform other techniques of evaluation such as heuristic, performance, and computation complexity. Here we have the references used in the presentation: measuring usability with the user questionnaire by Lounge, a technique for measurement of attitudes by Likert. Thank you everyone for attention. If you have any questions, send us an email. Jorge Pacheco Pinto and Cássio Prazeres. Thank you. See you.